This presentation is delivered by the Stanford Center for Professional Development.
Well, good afternoon, everyone, and welcome to the Thursday, October 11, 2012 session in our series on green transportation in Asia. And today, we're going to take a very large kind of policy overview and look at some new technologies and new government-funded programs that are coming out of Japan. Before I introduce our speaker today, though, a couple of business items. If you are registering for credit and you were not here last week, please be sure and fill out the survey form and give it to Tiffany in the back. And if you were here last week and have signed up for the course for credit, your name is most likely going to be on an attendance sheet that will be passed out sometime during the session today. Make sure you sign it because that is the record of your attendance. If we don't get a record of your attendance, you don't get credit for the attendance. And as you know, that's one of the requirements for getting credit. So please make sure you sign the attendance sheet. I'd also, on behalf of the U.S. Asia Technology Management Center, which produces this series, like to thank the Alan Miner Foundation for additional financial support of this series. We had a great session last week, including the standing around talking part afterward. And that kind of thing is very much due to the kind financial support from our sponsor. So please enjoy the time after our formal talk today, as well as during this session. I was also really happy to see some of the first written comments coming in from this session this past week. People are doing a great job picking out interesting things to comment back to me. And that makes me feel good because it shows that you're engaged in the session. So look forward to seeing those. Remember, comments are due 2 weeks, within the first 2 weeks after the date of the session. So all of the comments from last week will have to be turned in by next Thursday this time, okay? Today, it's a real pleasure to welcome back a Stanford alum to come and speak with us. Mr. Osamu Onodera was an MBA, got his MBA from the Graduate School of Business here at Stanford. And he is now a senior official in this organization called NEDO, the New Energy and Industrial Technology Development Organization, which is a government-related organization in Japan that administers funding and projects, most of which come from the Ministry of Economy, Trade, and Industry. And it's in charge of new R&D projects. In some ways, NEDO in Japan is sort of corresponds to an organization like DARPA in the US. But of course, economy, trade, and industry has nothing to do directly with defense, unlike DARPA. But funding a lot of big projects in areas that range from energy efficiency and smart grid to biotech, information technology, and nanotechnology. Mr. Onodera is the chief representative of the Silicon Valley office of NEDO since 2010. And as such, he represents NEDO all across the Western U.S. And as we're going to hear today, NEDO is involved in supporting smart grid projects in New Mexico and also in Maui, as well as other kinds of projects between the U.S. and Japan. Before his NEDO position, Onodera-san was with METI, and he was responsible for international issues in energy conservation and renewable energy development, including U.S.-Japan cooperation in clean energy and in the smart grid. He's also been involved in several multinational initiatives in this area. So let me turn over the microphone to Mr. Onodera. Thanks very much for coming today.
Thank you very much. Thank you very much for having me. So So my name is Osamu Onodera from NEDO. Dr. Dasher did an excellent presentation of my credentials, so I'll pass on that. It's a pleasure to be back here in Stanford to give a short talk on green transportation policies and examples from Japan. So here I have set out the agenda. First, I start off with an introduction. Next, I'll take an overview about the transportation sector and the reduction of CO2 in Japan. Next, I'll talk a little bit about EVs and EV policy. And after that, I'll talk also about the potential of fuel cell vehicles. And then I'll touch upon a little bit on NEDO's project that we are doing in Hawaii as it relates to transportation. First, energy is a global challenge. Probably there's no need really to go through all of this, but this is upper left side is a slide from IEA. It talks about how much CO2 has to be reduced in order to meet the CO2 reduction goals to reach what's called the blue map, which is to try to stabilize climate change at about 2 centigrade degrees above current levels. And this is how much CO2 we have to reduce. We have to reduce a whole lot before 2050. And most of that is through renewables and also energy efficiency. And if you look at this part here, the blue part here, a lot of that actually will be have to be done through transportation. You can see also CCS, carbon sequestering, and also nuclear in there. Now, in order to reach that, IEA has also done a lot of work in terms of what kind of investments will be necessary. It doesn't talk directly about the CO2 emissions in or reductions in the transportation sector, but you have to do 35 plants of CCS, 20 plants or 30 plants of nuclear. We have to invest this much in wind onshore. We have to build 55 concentrated solar power plants, etc. So we have this much of investment to do. Now, this blue part is what we have to do, and this brown part is what we have been doing. So actually, looking into the investment that is necessary, actually there's a huge amount of investment that has to be done between now and 2050. If we look at the global clean energy market, according to Bloomberg New Energy Finance, actually from the level of 53 billion in 2004, it has been increasing to 260 billion in 2011. So actually, even now, at this meager level, we have been already increased the global clean energy market by a huge amount. And that shows how much investment potential there is in this market. This is a slide which I often use, mainly because it tells you something that is common sense. You divide CO2 emissions and by energy supply, multiply it by energy supply, you get the same thing. You divide by GDP and you multiply by GDP, you get the same thing. So the right-hand side and the left-hand side is the same. Now, what we want to do is to reduce CO2 emissions, but at the same time, not decrease GDP, but rather increase it or keep it. Now, in order to do that, you have to reduce these two. So this is CO2 emissions over energy supply, which means non-fossilization of energy supply. So you have to promote nuclear energy, renewable energy, etc. You have to also decrease this energy supply over GDP, that is energy efficiency. So this is promotion of energy efficiency as a whole. So you have to decrease these two to reduce CO2 emissions and increase GDP at the same time. So this is very common sense, but this is something that we have to do. One of the things that we are thinking in Japan and actually around the globe is this concept of smart community. I think you've heard the word smart grid in a lot of places, maybe, for those people who have been involved in the energy area. But this is a concept that we are trying to promote in NEDO. And we actually established a new department called the Smart Community Department, mainly for that purpose. If you look at the power sector in the past, it's kind of, you have a main grid which has centralized power and sending it to various uses, like buildings, like houses, like factories, etc. So that's the kind of old grid that we have been having. One concept that we have is smart grid, which is to try and make the grid smarter to facilitate more renewable energy, that is wind power and mega solar, which kind of fluctuates depending on nature. And in order to kind of match that, we need to make the grid smarter so that it can do power flow in both ways. Especially in the case of Japan, because of our kind of energy situation and land situation, we have to have a lot more emphasis on rooftop solars and distributed generation, because we just don't have the wide lands in US. One thing that is, one point of difference between the smart community concept and the smart grid concept is, one, how to use heat at the same time. Actually, when you generate electricity, you emit a lot of heat. And one of the things is to how to, and if you look at the power plants right now, they waste up to about 60% or 70% of the heat when they are generating electricity. So one of the keys is to do cogeneration and try to use the heat as effectively as possible. That's one difference between just a smart grid and a smart community. The second point is to include the aspect of transportation. So how to link transportation effectively into the grid is also a very interesting part of this. Especially as you know, EVs are actually have batteries in them. And these batteries actually can be used to help the grid as opposed to hindering it. So those are kind of two major parts that are of the smart community. Let me next look at the energy consumption situation in Japan. This maps from 1973 to about 2007, which is not most recent, unfortunately, but you get the general idea. So GDP has increased between 1973 to 2007 2.4 times. So we have been able to increase GDP, having economic growth. Now, if you look at the energy growth in that period, in million kiloliters in crude oil equivalent, it has been increasing. Having an increasing trend in accordance with the GDP growth. But if you look at the industrial sector, commercial, residential sector, and transportation sector, you see that the industrial sector has been a very, very good pupil in maintaining, keeping the energy use in that sector down. So if you look at between 1973 and 2007, it has been flat, which is actually a remarkable, when you think of the fact that GDP has been growing by 2.4 times. But if you look at the commercial residential sector and the transportation sector, it has been growing. So that's the general kind of trend that you have in these sectors. The industrial sector, because it's relatively small, you have to deal with a relatively few number of people, it's much, much easier to reduce CO2 consumption than in the transportation sector and the commercial residential sector. That is not to say that, and if you look at the transportation sector, it actually uses about a quarter of the energy use. So in order to reduce CO2 emissions by a huge amount, you have to tackle the transportation sector. Let us look at, take a closer look at transport. The left-hand upper side, transport energy use has stabilized the total from about 2000, and it's actually reducing a little bit. Share of passenger transport has been increasing from 52% in 1990 to 62%, and cargo has been is like this. If you look, divide these in two sectors. In passenger transport, the share of automobiles, railway and air is stable. Automobiles in Japan is about 2/3. But this shows actually that in order to reduce energy consumption in this transportation sector, you do have to tackle passenger transport, especially automobiles. In cargo transport, share of automobile truck has increased from 50% to 63%. That mainly is kind of a factor of people want to have more convenience. If you go to Japan, it's actually very, very convenient because you can have deliveries on time, and a little bit different from UPS and the cargo delivery system in US. You can actually say, oh, between 10 a.m. and 11 a.m. So it's, people have been going from just morning to a very, very specified time, very specified times, and that actually increases the amount of energy that is used probably to make deliveries, but that's a matter of consumer preferences. This is an excerpt from the METI's long-term energy plan that was made in 2010. And this looked at what the consumption of energy in the transportation sector has to be in order to meet Japan's CO2 reduction goals at that time. Now, having said that, I'll give a proviso in that the METI's long-term energy plan is in the process of revision, mainly because of the tsunami, earthquake, and the change in the situation related to energy. According to the 2030 energy plan by METI at that time, a lot of the CO2 reduction was supposed to be done through the increase of nuclear power. From 30% to actually 50% of our electricity was supposed to be provided through nuclear. Now, as you know, with Fukushima, that is no longer possible. And probably they are saying either 0% or 15% or 25%, as the case may be. And so, I do not foresee any possibility for actually increasing the dependence on nuclear. That is shorthand for saying we are either not going to be able to meet our CO2 reduction goals, or we will have to do something much more drastic in terms of renewable energy, etc. But so that's kind of some notes on that. But the plan was to reduce from 245 million tons of CO2 to 154%. So 37% reduction compared to 2007. And the ways to reduce that was first, diffusion and fuel efficiency improvement of next generation automobiles. Diffusion is kind of trying to increase the deployment of. Biofuels, although biofuels is not a really good option for Japan, mainly because we do not have the big farming kind of that the US has in terms of corn diesel or what have you. The third is to do this through modal shift. That is increasing the share of railroad and coastal shipping and for mid and long distance transportation. So those were the kind of options that were being considered, and that was one of the things that those are the things that are to be used in the transportation sector. Now, based on that, and next, I'll talk about what are next generation vehicles. So next generation vehicles, as you know, you have biofuel cars, natural gas vehicles, clean diesel vehicles, hybrid cars, electric vehicles, fuel cell vehicles, plug-in hybrids, and hydrogen vehicles. So those are kind of some of the options that are on the table in terms of next generation vehicle options. I'll touch upon a few of them and some of the characteristics of each one. First is the hybrid. So hybrid, as of the end of 2010, we had 1.4 million vehicles in Japan. And they are actually the mainstay of what would be termed next generation vehicles. They can reduce CO2 emissions up to 50% compared to current vehicles. But challenges include cost and improvement of batteries, and as I'll talk about a little bit later, we have been putting in place subsidies to try and promote the changing over of the fleet. Toyota Prius, and there are numerous others that I won't touch upon. EVs, electric vehicles. As of end of 2011, there were 18,000 vehicles in Japan. And the Nissan Leaf, although the iMEV by Mitsubishi was kind of the first EV, commercial EV on the market, there's been a really large increase with the Nissan Leaf. They can reduce CO2 emissions by 40% or even down to 0%, depending on what kind of fuel you use or electricity you use. If you use photovoltaic panels to completely fuel the EV, then you can go down to 0%. But the normal thing is, right now, it's about 40% or something like that. There's one of the keys, as I will touch upon later, is the need for charging infrastructure. And there are possible range problems at the moment in terms of the current EVs on the market, except for maybe the Tesla, which actually costs a lot more. And then, some examples is the Nissan Leaf, Tesla, Mitsubishi i-MiEV, etc. Plug-in hybrid is kind of a good option that's in the middle of the hybrid and the EVs. In short range, it can be used as an EV, although the plug-in hybrid EVs right now have a relatively small range. So actually, unless you have a very, very short range, it's going to eat into the hybrid part. And in long range, may be used as a hybrid. So it does not have the range anxiety problems that an EV has. There's also less need for charging infrastructure, which is very, very good. The plug-in Prius, Chevy Volt, plug-in Honda Fit are some examples of that. And then finally, fuel cell vehicles. They actually have great potential in reducing CO2 emissions, and most large vehicle manufacturers are developing these vehicles and are eager to try and commercialize those. 2015 has been set as the target date for commercialization by a lot of companies. Again, this actually has a great need for infrastructure, and the cost of each vehicle is actually a bigger problem than EVs, and also the cost of the infrastructure is also a big problem. There are a number of fuel cell vehicles that are coming maybe on the market in 2015 or so. This is the diffusion or deployment projections and targets that were kind of calculated by the Ministry of Economy, Trade and Industry in a what's called Next Generation Vehicle Strategy 2010. So that's kind of was this considered more or less in tandem with the 2030 energy plan. So it kind of tries to show. The left-hand side is if the private sector is left on its own, they were projecting that this will be the case. So in 2020, conventional vehicles will continue to be about 80% of the market, and the next generation vehicles will be less than 20%. And in 2030, it will increase marginally, but relatively timidly. EVs and plug-in hybrids will be about 5 to 10% of the market, maybe, and will be increasing to this amount. So that was kind of the projections that they had.
Quick question: is that production based, or is that how?
Yeah, that's on an annual basis. Okay. So annual kind of deployment basis.
Okay.
And this is kind of like the government targets that were set in order to meet, at least to a certain extent, the targets, CO2 reduction targets that we had. And of course, here we're trying to increase the next generation vehicle to up to 50% of the market, and EVs to and plug-in hybrids from the 5 to 10% to 15 to 20%. So in order to do this, well, you need to have a lot more things put into place. And so that's, I think, one of the logics that was used to put in place the relatively robust subsidies in this area. Yes?
What is CDV?
CDV, clean diesel vehicle.
Okay.
So I guess diesel actually has better fuel efficiency than normal gasoline vehicles. And clean diesel is considered to be one of the options in terms of trying to reduce CO2 emissions. Of course, diesel will continue to emit CO2, but it's more efficient. Yes?
What are the share? You said it was 1.4 million hybrids. And what share of the market?
I'll talk on that in the next slide. So the number of next generation vehicles have rapidly increased to 1.5 million cars. As I said, partly hybrid and very, very small, minuscule amount EVs. So if you look at, but this is still about 2% of the general fleet. So it's still very, very small. It's been increasing at this pace, but as you see, most of them have been the green part, which is the hybrid. So you have a little bit of natural gas, a minuscule part of an electric vehicle, and almost zero fuel cell vehicles, of course, except for demonstrations. And if you look at EVs have increased, but even if you look at here, EVs are still only 1.6% of the next generation vehicle market in 2010. And I'll move on to my discussions on EVs. But having said that, EVs have been increasing quite rapidly. So EV sales are reaching over about 1,000 monthly. We've stopped around, the newest data is around January 2012, unfortunately. But I've heard that it's relatively above 1,000, although not as kind of, rapid as we hoped it will go. So the Nissan Leaf has made a measurable impact in terms of the rate of expansion of electric vehicles in terms of monthly sales. So about 1,000 monthly.
And what's that spike there?
That's when they kind of started. I think this is the result of the subsidy, I think. Yeah. So basic direction towards diffusion of EVs, the cost, creating initial demand and reducing cost by producing economies of scale. So as you increase the economies of scale, you'll be able to decrease cost. That actually is something that we have been doing in the area of photovoltaics. I won't dwell on that this time, but in Japan we had relatively robust photovoltaic subsidies in place, and that was actually one of the things that allowed the initial reduction of the cost of photovoltaic panels. And after a certain amount, and you get a certain amount of price, then you start to increase the market quite rapidly.
So maybe it's just me, but I'm very unfamiliar with these subsidies. Can you go into more detail?
I will go on that later. Yes. Second, performance. So currently, as you know, EVs still have a range kind of limitation. I'll go into that later. But so in order to change that, you have to increase the battery performance. Also, as I said, infrastructure is very, very key in order to promote, increase the deployment of EVs and have consumers more comfortable with the idea of having EVs. And from that point of view, one of the things that the government has been doing is what's called EV and the plug-in hybrid vehicle towns. So the government actually cooperates with the local community. So they started off with these kind of Fukui, Kyoto, Nagasaki, Niigata, Aomori, Tokyo, Kanagawa, with these prefectures to cooperate together to one, increase the infrastructure of EVs, and at the same time try and get these prefectures to buy a certain number of EVs to kickstart the market, and also to increase the kind of consumer awareness of EVs. So that's what we've been doing, and this has been increasing to those prefectures in red. Now, if you look at the various EVs, plug-in hybrids on the road, on the left-hand side, you can see that the EVP plug-in hybrid towns have 66% of the total. And if you look at the quick chargers in use, again, these towns constitute about 63% of the total. Yes?
The numbers still look small, but this really only started in fiscal year 2011.
Yes.
So maybe from summertime of 2010 or so. Mm-hmm. And remember, plug-in hybrids have really just hit the market. They're, only the newest Priuses are plug-in, right?
Yeah. And,
Can you go back with the quick chargers? Are they which level
Quick
is it?
charger.
Is it what you would call here?
I'll go into that, yeah. I probably should start.
Well, we're doing okay.
In terms of charging infrastructure, there are what's called the normal chargers and the quick chargers. So normal chargers, these are like 100 volt, 200 volt, and they take about In the case of a 100 volt, 14 hours to fully charge. In the case of a 200 volt, it takes 7 hours. The quick charge, it takes approximately 30 minutes to fully charge, but in order to get a half charge, it's a little bit less than 15 minutes. So those are kind of allow a person to charge their car outside of their homes. Now, having said that, in order to to help out the grid, you want to minimize the amount of quick charging, and you want to maximize the amount of normal charging. So you don't want to put too much emphasis on the quick charge. But having said that, as I said, when you think of the anxiety problems that EVs can have, it's necessary to have a certain number of quick chargers to allow the consumer to be happy. I'll pass on this one. And in terms of installation, these private charging stations, they can have in the house, condominium, office building, etc. And actually, the condominium part is the most difficult part, I think. In terms of EV tourism, that's one of the things that it's been doing in the plug-in hybrid and hybrid towns. That is, try to increase the awareness of EVs and also to increase the kind of initial demand for EVs. And so this is an example I took from Kyoto. You can look at that later on if you want. In terms of policy for the diffusion of EVs, so there are three parts. One is to try to increase the efficiency of the batteries. So the departments at METI, they've put in place 26 million per year to try to enhance, accelerate the development of advanced lithium-ion batteries. They've also tried to put in 43 million per year to post-lithium-ion batteries. And also, as I said, because infrastructure is such a big part, they put in place 555 million to subsidize half of the charger price, and also incentives for purchasing EV, plug-in hybrid EVs, which provides half of the difference between the prices of EV, plug-in hybrid, and their base vehicle. So they put in place a pretty big amount of subsidies, mainly because this whole issue is kind of a chicken and egg problem. Unless you have infrastructure, people will not buy EVs. Unless there are EVs, people will not put in place infrastructure. So this is kind of a way to try and get around that problem of chicken and egg. I'll pass on these two. And you can see some of the kind of details regarding the charging infrastructure, etc. Now, in terms of EV charging infrastructure, so the target that the government has set before 2020 is to have 2 million normal chargers, which is pretty big, and also have 5,000 quick chargers around Japan. Of course, EVs should basically be charged by the normal chargers at night. That is the basic premise. But a certain number of quick chargers need to be in place in order to provide a safety net. And so the logic is, in order to prepare the market, one just have to provide some background information so that people can be preparing for that, and also provide subsidies in order to kickstart the market. Now, as I said, in terms of quick chargers, 5,000 is the target. But now, as of now, there are over 1,300 fast chargers in Japan, and 4,800 normal chargers available to the public. So they've been increasing quite rapidly in Japan. Now, I actually had a couple of slides that the Nissan was using in one of their conferences. Oh, okay.
Just curious, when you say available to the public, do you
Yes.
mean there's some that aren't available to the public?
Of course, if you have a normal charger at home, that's not going to be available to the public. If you have a charger inside an apartment building that is used only for those people living in the apartment, that would be, yes, a normal charger, but it will not be a public charger.
Do you know what the number is? 'Cause I think you said by 2020, 2 million normal chargers, which includes both public and non-public,
Yes.
right? So do you know what the current number is when you add in non-public chargers?
I'm not sure. I don't have that number with me, sorry. So going back to my presentation. I actually had a slide by Nissan, which I wanted to use, but they wouldn't let me. So I cannot use it. But as you know, currently a lot of the vehicles, the most advanced vehicles, they all have like some kind of GPS capability. So they know actually how much you've driven, what have you. And actually that came in very, very handy when there was the earthquake and tsunami, because using that data, they were able to see where the vehicles were being driven. And you can therefore deduce which roads are open or not, and which roads are not open, cannot be driven. And so that actually helped in the transportation right after the earthquake and tsunami. But, and so they are able to see which roads are being driven by EVs and how much. I'll go back to you. So if you look at the map of Japan right now, actually, everywhere except for Hokkaido and Tohoku is almost a mesh. So you can see that EVs are being driven all over. Now, how often they go from here to here, I don't know. But they are probably going a longer distance than they are in the US. Let me go to the next slide. If you look at the US, I think there are about 30 quick chargers in the US right now, mainly for some standard reasons that I will touch upon later. These are the number of quick chargers in the US. Now, if you look at the same map and you map the roads that EVs have been driven, of course, there is a line between Los Angeles and, there are some people who have driven between here and here. But what you see is small round clusters, except for a little bit, and you see a thin line between Los Angeles and San Diego and San Francisco. But all of these are a little small clusters. It's not a network yet. And the main reason that that is the case is because there are no quick chargers, and it will take literally, as I said, if you try to charge a car with a quick charger, a normal charger, it takes, 17 hours to do that, or 10 hours, as the case may be. So you just, unless you are an adventurer trying to make a point, you will not do that. So that is the situation in Japan and US. And there's a second slide also, which kind of was interesting, is that if you map out the people or how much each EV user uses, on an average basis, actually, US EV users drive more or drive longer distances than the Japanese EV user, which makes sense because of the wider area. But the interesting thing is, if you look at the avid users, the people who use a lot the EVs, then at around the 100-kilometer level, which is the turning point of whether you use a quick charger or not, it actually flips the other way around. So the heavy users of EVs in Japan actually drive them a lot more, up to 200 kilometers, etc. So that's a big difference in Japan and US EV market, which actually is a result of the relative lack of quick chargers up to now in the US market. Please, I'm sorry.
The previous slide with the chargers in Japan, there's a certain color coding. I'm just wondering what the color coding means.
Good question. I was thinking of looking that up, but I forgot to do that. If you look at the CHAdeMO kind of homepage, you will be able to get this map. So you should be able to figure that out. But I think, if I remember correctly, the green ones are where you just have one charger, and the others are kind of where you have multiple chargers. I think that was the thing, but I have not checked it out. Sorry, I knew that this was coming. So these are the kind of CHAdeMO compatible EVs that are already coming out. Actually, if you look at the EVs, it's not just Japanese vehicles, but you have Citroën and Peugeot and a number of other companies that are coming up as well. This quick charger issue is actually a result of how do you say, standardization or lack of standardization coordination between Japan, US, and the EU, unfortunately. So there's one, the CHAdeMO kind of standard was one that started off in Japan, and it's a charger that looks like this. If you look at globally, there has been an increase in CHAdeMO chargers around the globe. But in US, there's what's called the SAE standards, which look somewhat like this.
That's the Society of Automotive Engineers.
Yes, yes. Yeah. And in EU, they have a combo connector like this. And they weren't really able to kind of agree on a common standard. And so that's the main reason that, there has been some reluctance, I think, to put in place CHAdeMO connectors at the moment. But the thing is, in the case of the SAE standard, it was only agreed upon, I think, this year. They did agree on a standard about the format, but there are no cars that use the SAE connector charging standard on the market yet. And from what I've heard, maybe sometime next year.
So this is not only the shape and kind of size of the socket, it has to do whether it's AC or DC.
Somewhat, yes. Yes. It does have a little bit to do with that, yes. But I think the main issue was that the CHAdeMO was a kind of, it's a separate connector that has to be used for normal charging and quick charging, as opposed to this connector and this connector, which actually uses just one. So you have one connector, there's a normal charging and quick charging, and you can use either. Using just one connector. In the case of the CHAdeMO, you have to have one normal charging connection and as a separate. So it's a little bit of a difference in philosophy, and also in terms of the speed of the charging. The CHAdeMO connector, as I said, takes somewhat more time than the SAE and combo connector. But having said that, one thing that is of interest is actually, if you look at the quick charger installations, the power box enclosure, there's actually a lot of commonality between the chargers. And according to the discussions that I have had with charging station manufacturers, actually you are able to flip over a CHAdeMO quick charger and retrofit it to meet other standards. And so actually probably the standards issue is becoming no longer an issue in terms of delaying the kind of installation of quick chargers. So conclusion, what we have to consider now are trying to put an emphasis on users. I think there are a good number of EV users already in California, which actually are feeling a little bit somewhat stranded in terms of lack of infrastructure. And so how to try to ensure the compatibility of devices going into the future, but trying to put in place the necessary infrastructure for them. And constructive cooperation between the various manufacturers are going to be necessary going into the future. Next, I'll go on to fuel cell vehicles. I've already run out of time. Or, no,
you're okay.
I'm okay?
We'll take the time.
Okay. So industry trends for fuel cell vehicles and H2 stations. So as I said, fuel cell vehicles are another kind of a vehicle that is of great interest. Now, EVs are good for kind of shorter hauls, but they have to carry battery. So you don't want to put a huge amount of battery to haul cargo, etc. And so actually, fuel cell vehicles are said to be good for especially cargo-related applications. And if you look at the automobile manufacturers, as I said, they are all, be it BMW, be it Toyota, be it Honda, Nissan, etc. They are actually all trying to launch fuel cell vehicles. And so they are saying that they will start commercialization in 2015. Now, in order to kickstart that, what we want to try to do is to make an expressway between the four major kind of population centers in Japan: Tokyo, Nagoya, Osaka, and Fukuoka. And the hydrogen fuel suppliers, on the other hand, they think this might be a good business, and so they are aiming to construct approximately 100 hydrogen refueling stations by 2015. And hopefully they will work together to create a new market. So this is kind of a commercialization scenario which is being considered. So between 2011 and 2015, this is the market demonstration period. 2015, as I said, is the start of the sales of the fuel cell vehicles and early commercialization up to 2025. And then 2025 onwards will be the full commercialization. And so what they want to do is they want to try to reach approximately 1,000 hydrogen stations and approximately 2 million fuel cell vehicles by 2025. Whether that is possible in a period of 10 years from 2015, that's a pretty aggressive target, but who knows? We've had a lot of iPhones in the past few years. Now, for the first stage, a number of hydrogen stations are being put in place for demonstration of the technologies. So you can see that there are a number of fuel cell stations, especially in this relatively big corridor, as I showed you. And I'll say a few words on this 35 megapascal and 70 megapascal, etc. This is the pressure at which the vehicles are refueled. The 35 megapascal, which is the lower kind of pressure, is actually easier to do. And that is the kind of prevalent pressure that is being used right now. But the problem is that lower the pressure, the less gas you can put in. And if you have 70 megapascal, a much, much higher pressure, you are able to put in more fuel into the vehicle. And if you try to have kind of equivalent range between the fuel cell truck and the normal truck, you need to have a higher pressure. That is the key point there. A number of demonstrations are being put in place to prepare for this demonstration, like welcome home taxi service, airport taxi. Those are kind of like, because the fuel cell vehicle is still a very, very expensive vehicle, you need to try to do it in terms of, in an orderly manner, but you can't really do it for normal houses, etc. It's too expensive a vehicle to do that. So these are some applications that are being explored. They're also putting in place airport limousines, ramp bus, etc. to do fleet demonstrations. The number of hydrogen stations in Japan as of 2011 was 16, increasing to 19 in 2012, and hopefully more going into the future. So I think California is in a kind of a similar situation as this in terms of deployment. So with that, I will also go into some discussion about NEDO's projects in the area of transportation. NEDO actually, as Dr. Dasher said, is doing a number of projects in US and across the world. One is in the state of New Mexico, which is a kind of a smart grid / microgrid demonstration that we are doing in Albuquerque and in Los Alamos. The other is in Maui Island, which is in the state of Hawaii, which I will go into greater detail. We also are doing a number of projects in France, in China, and in Spain. This project in Maui is called the Japan-US Island Grid Project. If you look at the Hawaii, it's an isolated island. And so it has its peculiar challenges and opportunities. In terms of challenge, because it's a small island, it costs a lot to bring oil and gasoline from outside. And so if you've been to traveling in Hawaii, sightseeing, you can see that you get sticker shock when you go to the gas station every time. On the other hand, it actually has benefits as well. One is actually Maui Island and the Hawaiian Islands are blessed in renewable energy in terms of solar and the wind, etc. Another thing which is good in terms of EV is electric vehicle is that actually there is less room for range anxiety. If you are in Maui, you can only go so long before you hit an EV charging station. If you get a good amount of a good number of EV charging stations, and you can do it relatively small, fewer. And so there are pluses and minuses. So, and actually, Hawaii has this Hawaii Clean Energy Goals, which is to reduce its carbon emissions by 70%. By 2030, partly through renewable energy and partly through energy efficiency. And so they have pretty aggressive goals. And so the state of Hawaii and NEDO were discussing how we can do a project together. And we signed an MOU in November 2011 to do this project. NEDO will be covering $37 million for this project. Sorry, I actually talked about a lot of what's in this slide. But one of the things that large-scale renewable energy introduction will cause in terms of problems in Hawaii is there might be surplus power in the nighttime. Because in Hawaii, they use a lot of energy in the daytime, but in the nighttime, you have relatively less use, and actually you have a lot of wind coming in. So there are issues of surplus power. I don't know if you know much about the power area, but electricity has to be balanced in terms of demand and supply real time in order to have electricity, stable quality electricity. And so actually, if you go to a power company like PG&E, they are ramping up demand, supply, starting up new gas-fired stations, etc., in order to follow the load. So there are cases of surplus power. Also, because, in terms of frequency is the measure that you can see in terms of demand and supply. If there's too much demand and too little supply, the frequency starts to deviate from 60 hertz to become longer and longer and longer. If you imagine 10 people cycling to try to generate electricity for a light bulb over there. Now, if you increase the load, the generators have to push a lot harder in order to do that. And so frequency starts to go down, 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 because they have to roll a little bit harder. And so, but the problem with the power grid is that if frequency starts to go down, some of the generators starts to go off when because to protect itself from breaking down. If you have a gas engine that has a certain capability, if the frequency goes down to a certain level, they just go offline. And so that's one of the reasons that you have large-scale blackouts in various areas. And so you have these issues that are kind of concomitant with renewable energy introduction. And at the same time, actually, the more PV systems and the more EV you have on the grid, it can also have a lot of problems in the distribution line. So this is kind of an island-wide problem, and this is a kind of very local problem. So you have these two issues, and you have to figure out how to solve both of them at the same time. And so what we are doing in Maui Island is to put in place an island-wide smart EV system to try to coordinate the charging of the EVs so that they do not coincide at the same time. For example, if I drive an EV back home, I plug in the EV at 6 p.m. Everybody does that at 6 p.m. You have a blackout, probably, if you have a good number of EVs. So what we want to do is to try and stagger the charging between 6 p.m. and 7 a.m. or 8 a.m. as the case may be, so that the load will not be coming on at the same time. At the same time, you have these local problems, as I said. If you have a certain number of EVs in that kind of pole-top transformer or the feeder, and they all charge at the same time, this will blow up. And so you don't want to have that either. So you want to try to coordinate this and this at the same time. And in order to do that, you may need to have more intelligence in the grid. And so that we're putting in place an island-wide EV charging system and kind of a localized control system in an area called the Kihei district in Maui Island. So we are also considering trying to to expand that to include vehicle to the home and vehicle to the grid, which is actually something that is being commercialized in Japan, especially the vehicle to home part, as there is a bigger, anxiety towards energy supply after the earthquake and tsunami. So with that, that concludes my presentation. I'm sorry I've taken a little bit more time than I should have,
We
but
still have some time for Q&A.
Yes.
Thank you very much for very interesting. So let me lead off with a quick question. After the disaster in 2011 and Japan may be shifting away from nuclear power toward more renewables, is that going to impact the mission of NEDO in terms of how transportation fits into your overall policy picture?
Yes, I do think so. I mean, in terms of the hydrogen fuel cell vehicle program, I think METI has been putting in place a lot more emphasis on that area. Also, the EV part as well. I think there's been a very big push to
Since 2011.
Even since 2011. So I think that is something that will be,
Okay, thanks for letting me go first. Questions open.
let me see.
I know that in Japan you've had subsidies recently towards hybrids. And are those the same as for the EVs? This half?
No, the EVs are different.
Right.
Yeah, they have a little bit more.
And just if you know, like, what are the subsidies for hybrids and what effect have they had? Because they're kind of interesting from a subsidy point of view, since normally subsidies are to early adopters and hybrids are kind of past that in Japan.
I'm sorry, I don't have the figures with me right now.
Okay.
Actually, there's one interesting difference that I'd like to mention. You know, here in California, one of the things that promoted use of hybrids was being able to use the carpool lanes.
Yeah.
And I'm unaware of anything like that in Japan, or any kind of reduction in freeway tolls as a result of using next generation vehicles.
There is, as you say, I think the main reason for that is because actually cars are not used that much for commute, especially in Tokyo or the large urban areas. And so it is less of a kind of an incentive.
It wouldn't,
I mean, of course, places I know of that where cars are used extensively for commute is like Okinawa or you know areas
or
like
regional
that.
cities.
Regional cities, yes, but for large population centers, I don't think it's they are not being used for commute purposes.
Yeah. Okay.
So
Thanks.
I'm interested in these quick charge stations. It seems actually like kind of a misnomer to me because they still take 15 minutes, right? Which is considerably longer than stopping at a gas station.
Yeah, but that's not 6 hours.
But it's a really awkward amount of time. Like if you're on your way home from work, you don't necessarily want to stop for 15 minutes. And if you're like, you can't really do anything else with that time, it seems, because it's not long enough. So like, I would almost rather get to work, plug my car in at work, and then be good for the drive home.
Yeah, definitely. I think the premise of the quick charger is not to be used in normal use. And so the normal use is between the house and the commute is you have a charger at home and you have a charger at the workplace. And that is the main kind of mode of charging. Now the problem, a typical problem is, for example, if you are having a car in San Francisco, and you have an appointment in San Jose, and I was talking with this person who was doing that, and a lady was visiting this person in San Jose, and she called him and said, "Oh, I have an EV. Is there a charger in your office?" And he says, "No, we don't have a charger in the office." And so she could not take the EV to that office. And so she decided to use her second car, her husband's car or what have you. Now, that person was saying that that was a sign that EVs are too early for the market, which I don't really agree with, because if you had that charger, normal charger in the office, in that building, that person would have been able to come and just charge, get a small amount of, addition, and probably have been able to drive back. If you have an hour meeting or a 2-hour meeting, you just have a little bit of top off. Now, that is the main model. But having said that, there might be a case, but if you were able to go to San Jose and you had that appointment and you had a quick charger, you could just go to the quick charger and charge a little bit. Now, you may not need the full charge. You may just need to charge up to 15, up to a certain amount. Now, if you look at the quick charging station kind of deployments in Japan, they are typically done in front of convenience stores. Now, they think that that's a way of getting consumers into their shop. Now, 15 minutes. You can use 15 minutes inside the convenience store, browse through some magazines, etc., and hopefully, as they think, buy a few things. So I think it really depends on, if the quick chargers are put into place at the right locations, I think they definitely can serve as a kind of an increase in kind of or decrease in anxiety.
Can we switch over to here for a question?
Okay.
My question is about the batteries. In Japan, for a lot of EVs, are they using lithium-ion battery or there are some other batteries?
They are still using lithium-ion batteries, mainly, from what I understand. But as I said, because there are some limits to the effectiveness of lithium-ion batteries, that's the main reason they are trying to take both routes, in terms of, one, trying to improve the existing lithium-ion batteries and trying to figure out if the next generation of after lithium-ion batteries.
There are a lot of issues in China in terms of battery consistency. When they try to promote the electrical bus, I don't know if there's a similar consistency issues in Japan. Of course, a bus is a lot bigger than cars. I think your example is mostly for the small, medium-sized car or small car.
I am not aware of such problems. Sorry. Yeah. Please.
Yeah, okay.
There's a new initiative called Drug and Plug by Walgreens. They're going to be, I think they have 1,200 stores, and they're going to be installing charge systems. And I was wondering if that is a possibility for Japan too, because are there drugstore or convenience, not convenience store, but drugstore chains?
So as I said, a lot of the retail store chains actually have been putting in place quick chargers and normal chargers, mainly because they think that it is a way of getting customers into their shop. It's like, to use an old example, in the old days, shops used to have salt in front of their shops to get horses to come and eat the salt, and because of that, the Japanese shops still put salt in front of their restaurants, etc., to try and get. It's a mythical thing of a sort, but it's a way of trying to get customers to come to their shops. But anyway. So,
Charlotte, I think. Let's go back in the back first.
Okay, back. There.
They don't have good studies of what's been the increase overall to the use of electricity in Japan, as EVs have increased in use and all the quick chargers and all the stations. How much has that increased the need or the demand in the overall grid in megawatts or gigawatts?
I don't have that right now, but in terms of the number of EVs right now, I mean, I don't think it's a
think it's
measurable
significant.
impact on the grid as of now. Yeah,
Well,
but
of the 1.5 million next generation vehicles, almost all of them are hybrids that are not even plug-in hybrids, right? And so the EVs are still less than 100,000
yeah,
or so,
yeah, it's
somewhere around
yeah.
there.
So they have not come to the kind of extent yet where they will have an effect on the grid. Please.
So you mentioned next generation vehicles were selling at 1,000 a month.
Yeah,
What
the
are
EVs.
that's a 2% of the vehicles are next generation. What are the sales of non-next generation of just regular gas per month?
Per month. Oh. Sorry, I don't have that with me right now. But one can calculate probably from this, yes. I'm sorry, I don't have it off the top of my
Yeah,
head.
I don't have that either.
Let me see. Okay, please.
Go ahead.
So I was curious about post EV, like once the car is okay. So assuming that you hit market saturation, and I think you mentioned you wanted Japan was aiming for something like 20% of like all users that have EVs. Is there any kind of recycling? Any recycling program set up at all for disposal of the batteries? Is there anything?
There are a lot of demonstrations actually being taken place right now in terms of trying to use EV batteries for second use. Now, what I mean by that is that when you increase the amount of renewables into the grid, you are going to have balance supply-demand problems. And so batteries are one way of trying to balance the supply and demand real time. Now, batteries are still quite expensive. Now, having said that, if you can use the EV batteries second-hand and use them on the grid, then you can probably decrease the cost of the batteries that you are putting into the grid, as well as perhaps reducing the cost of the EV, initial cost of the EV, because you'll be able to sell the batteries. Now, that does have several problems, because if you have EV batteries that have been used to different extents, you have batteries that have, maybe 70% of their capacity left. You might have some that have 50% of their capacity left, etc. And so it's going to be an issue about how you can kind of coordinate the various batteries in a meaningful way without costing too much. Now, that kind of demonstration or test is being conducted in Japan and also in the US, I believe. I forget where, but that is being considered, yes.
So the idea is that the battery will outlast the vehicle. People will change their vehicles every 3 years or so, and so the batteries will still be good.
I mean, the thing is, if you decrease the range from 100 kilometers to 70 kilometers or 50 kilometers, it becomes really unusable as a car. But that's still a battery that can be used if you have enough of them there. So, so that's kind of, I think, the idea behind that.
Okay. Mark.
First of all, I'm a owner of the Nissan Leaf, and you said that there are two issues for the EV, and one is range, and another one is infrastructure. I think this is true in the US, but I think that there are two more issues in Japan. One is cost of electricity. I pay about $7 to $10 per month for my Nissan Leaf, compared with I paid $150 per month for gas car. And the second issue is that people don't have a garage. And I have a charger station in my home, but the people cannot have a charging station. And most of the people has rent a parking space near to their apartment. So there are two issues in Japan. Is there any idea Japan is thinking?
I think what you say is very true in terms of in Europe as well, because they park their cars not necessarily inside the garage, but outside in many cases. And it really probably will become an issue of, how to have public charging infrastructure outside in the street, for example, in the case of Paris or something like that, or in the case of a home or outside parking lot, you have to do charging outside. You can probably do that, but you just have to, how do you say, put in place different kind of equipment to allow
Do you
for
know
that.
if anyone in Japan is doing some sort of a subsidy program for public parking garages to have a certain number of spaces for EV charging? Or
I'm not sure, but they are also able to apply for the subsidy. As I said, you can get one half of the cost of charging infrastructure installation be subsidized, and so by using that, you can do that.
Okay. I saw a question over.
Yeah.
Go ahead.
I was just wondering, do you know if there's any data of how much the quick chargers are actually being used? Because sometimes there's discussion of that they're necessary, but that people actually don't really need them because they charge most of the time at home or at work.
I'm sure there must be data, but sorry, I have not looked at that data. But what you say is correct in that a lot of the quick chargers are not used that, how do you say, that much. And that is how it should be, in a sense, in terms of trying to decrease the increase in demand of electricity in the daytime. You want to have them charged at nighttime when you have relatively cheaper electricity rates and when you have relatively abundant electricity. But as you say, a lot of the quick charging infrastructure is not used as much. And so it creates a big business model problem for those companies who put in place a lot of quick chargers, thinking that there might be a lot of charging people. But even when the EVs increase, the amount of charging does not increase that much. So, but at least in terms of qualitative evidence, what you say is correct. Please, or actually,
I see three in one order or another. Yeah.
I have curious about technology of charging and battery. If you use super high technology with charging and battery, how long does it take to charge the full? Even if it is not cost effective.
I'm not exactly sure. The CHAdeMO takes about 30 minutes, as I said, but there are some technologies like one by, I forget the name of the company, but that does it in a much shorter time, like 15 minutes. But from what I've heard, it may have negative effect on the battery. And so, it really is an issue of what kind of effect it will have on the battery. So and even in the case of the CHAdeMO standard, what they do is they charge relatively rapidly at the beginning, and then as it becomes near the full charge, they kind of slow down the charging. So at the end, they kind of trickle charge near to they reduce the voltage, and so I think. I think the Tesla kind of charger tries to have a much bigger, faster kind of charge, but I think that that kind of takes a toll in terms of the cost of the charging infrastructure, etc. So it's a balance between those two, I think.
So I saw two other hands. Marty?
Yeah, I'd like to ask you about the source of electricity in relation to the EV. In 2025, was it, when the commercialization starts? Do you have any idea of how much % of the electricity comes from the renewable energy?
That is anybody's guess, I think. In terms of that's what they are trying to discuss right now. In terms of what the energy how do you say, the percentage will be in 2030. Now, I would guess it's somewhere around 20% or something like that, as they are thinking about right now. And they are going to be, if they reduce nuclear, what they would probably do is increase gas. Now, it really depends on how fast we can deploy renewable energy at a relatively, how do you say, cost-effective manner. But it's really anybody's guess, I think.
Promoting EV is to reduce the CO2 level or whatever, right? Environmental issues.
Yes.
So if you depend on the fossil fuel, does not make much sense.
But Marty, think about it. Right now, EVs are such a tiny percentage of the total number of vehicles. If you get up to 12% of the vehicles on the road being EVs, then you've matched the current percentage of renewable energy that's being used in Japan. Right? The transportation sector is almost all fossil fuel. So any increase you can use in the number of EVs is going to go with the national average. And as long as the national average is better than 100% fossil fuel, right, then you've made an improvement.
And it really depends on what kind of energy, when the energy is being made or produced, and when it is being consumed. Now, if you look at the energy situation in Japan, roughly speaking, nighttime electricity is more abundant than daytime electricity. And so if the EVs are going to be charged in the nighttime, it still makes a lot of sense. Now, but that is based on the premise that there is abundant nuclear. Nuclear is a base load, and gas is kind of more. But even then, if you look at the demand structure, it's still the case that the daytime electricity is more more in demand than the nighttime. So, in so long as EVs charge at night, it probably makes a lot of sense to increase the EV fleet. Now, it also, if you are able to increase the amount of renewable energy going into the future, it kind of allows for more smoother transition. Now, fossil fuels probably will last for 50 years, even maybe 100 years, who knows, 150 years, I don't know. But they will have to be weeded out at some point in time. And probably electricity is the most kind of fungible fuel source. And if we have 100% fossil-based transportation, and if you have a 30% fossil-based transportation, it's going to be a big difference, because you're not going to be able to change from here to there in 5 years.
We had one more question that I saw somewhere around in here. Yeah, go ahead.
So on one of the slides, you mentioned that using an electric vehicle in Japan, after you account for the CO2 emissions of the energy production, it would be about 40% reduction in CO2 emissions, right? But there was also something next to it that said 0% using photovoltaics. Is that a plan? That sounds like it would be really hard to implement.
Oh yeah. It's not really a plan. It's just a matter of fact that if you use electricity, you can reduce CO2 emissions by anywhere between 0% and 40%. Now, the reason for the 40% is that in the case of combustion fossil-based automobiles, you are actually emitting a lot of heat at that time. And although the gasoline engines in a car are quite fuel efficient than they used to be, they are still less efficient than the most efficient gas turbines generating electricity. So as a combination of that, you are able to, by using EVs and the current fuel composition in Japan, you are able to reduce CO2 emissions by 40%. But of course, or to 40% of the current vehicle. But on the other hand, if you are able to change over to all nuclear and all renewable energy, for example, or something like that, which probably needs to be the case in 200 years from now. Let's pick a number. Then, or 300 years, that's the case maybe. Then it will be 0%.
Okay. I think that it's time for us to call an end to this session. We've got some refreshments outside. Hope you'll stay around and talk for a little bit. please talk with our speaker outside so we can clear this room. Thanks, everybody. Thanks for coming.